Hey everyone, thanks so much for joining our webinar today. We appreciate you taking the time to be here. We'll wait a minute or two to allow everyone to join, and then we'll jump right in. Just a quick note, we will be recording this session and sharing it afterwards. We'll also have some time at the end for a Q&A, so please feel free to drop your questions in the chat as they come to mind. I'll be moderating the Q&A chat for any timely questions, so feel free to raise your hand at any time, but any in-depth questions, we will address them at the end. All right, my name is Lexi Lutz. I'm the marketing manager for Plainsight Technologies. To start off, I'll go through why anyone would want to build a computer vision app, why it's hard, and how Plainsight software makes it easy. Navar Nascimento will be delivering the technical portion of the webinar. Navar is a ML AI engineer and data scientist with 8 years of experience and has published over 20 papers in relevant scientific journals and conferences. So, why you want to build a computer vision app? People are very bad at doing repetitive manual things, the things that businesses need people to do. We're good at processing visual information, but we're bad at quantifying visual data, counting, measuring, and comparing at scale. We don't like to do it. We prefer to take breaks in that this makes the data inaccurate and slow. Computer applications can go a step further. We can do a bit more advanced form of counting than human beings, but the real value is in performing complex operations at the speed of a computer, like inspection or maintaining the accuracy of quantifying large groups. Computer vision allows you to get the clipboards out of people's hands and make your cameras count. One does not simply build a computer vision app. Don't get me wrong, app development isn't trivial, but the hard part is building and maintaining the models that power the computer vision. That by itself means you need machine learning skills to build a useful model. Let's say you build a model for inspecting a product. What happens when the product changes, or the lighting in the room changes from fluorescents to LEDs? Update or completely rebuild the model. If the models change, was the app built to support a different model? If it wasn't, now you have to change the app too. Plainsight filters are containerized applications that turn cameras into spreadsheets. Filters on Instagram enhance a photo, also known as lying. Plainsight vision data filters create an abstraction of visual information, whether it's about inventory, equipment, or people, to generate the business critical truth. In this example, we have a raw image of an elephant being passed into an elephant counting filter. The CV model identifies the elephant and creates a layer of abstraction on top of the image that the application uses to quantify it. It runs on Docker containers, making it deployable in Kubernetes, and outputs CSV or JSON files using universal protocols like MQTT or HTTP. The data can then be ingested by whatever data lake or automation environment a business might use. By the way, the elephant's name is Seymour, and he lets us talk about the elephant in the room. Our CEO is a bit camera shy, so we opted for face blurring as our first demo today. This is an example of a pre-processing filter that we can use to prevent the storage of personally identifiable information in order to be more compliant with regulations like GDPR, and then chain a business use case to it afterwards. Behind the scenes, these filters are powered by our proprietary infrastructure, the Filter Factory. The Filter Factory is where the real magic of Plainsight happens. Think of it as our Willy Wonka's chocolate factory, but for computer vision. The key to our approach is the feedback loop that improves the filter over time. The first step is installing the data acquisition filter to upload your visual data into our system, the golden ticket. Once the data is in the Filter Factory, we label the images using active learning workflows to help automate much of this process and boost model performance, removing the undifferentiated toil. This helps you quickly build and production-ready models. Next, you define the filters using business logic and perform benchmarks to fine-tune your model. Once a filter is built, it's stored in a repository where it receives regular updates from Plainsight for security and performance improvements. Finally, the application exports the processed data to whatever your enterprise data resides, like a data lake or a business intelligence tool. Over time, the system also provides suggestions for improving your model using DevOps principles. You'll notice there was no mention of complex machine learning, data science, or infrastructure expertise required. Without further ado, I'll hand it off to Navar to show you how we turn your model and business logic into a filter on filter box and use it to generate data for export, where the arrow is pointing on the side.
Thank you so much, Lexi. I hope you all can hear me now. So thank you all for joining this webinar. Thank you, Lexi for the talk here. I would like I'm very excited to know that you guys are taking an interest and learn a little bit more about computer vision here and how we can write software here at Plainsight. And before we jump our hands into any code here, this webinar requires that you have some basic programming knowledge. If you have that, I think you should be good to go. More specifically, if you are familiar with Python, you should be even better and follow along with the tutorial that I'll show here today. And I'm gonna present here some unreleased materials, so the code is not open sourced yet, but if you like, or if you feel that you want to get your hands on it, just let us know, reach out to the Plainsight team or even me directly, and we should be able to help you out to get your hands in the very first alpha version of our software. So let's get started here. So we have this beautiful library called filter runtime inside the filter box environment here. And what the filter runtime basically does is it can provide for you a lot of utility and building blocks for you to build your filters upon it. So it has a lot of utility in infrastructure code, so you don't have to deal with all of that. You just need to focus on what really matters, which are building the innovative solution for your business-oriented problem. So, well, and I also gotta say, the first time that in the past experience, I struggled many times having to rewrite a lot of boilerplate and infrastructure code when switching to a project over another. And the very first time that I got my hands in a filter runtime, it just seems so much easier to write code, especially or even if you're just a developer and you want to improve your day-to-day work as a computer vision engineer. That's something that you'd like to have your hands on it. Before we explain any code, let me just show you this thing up and running so we can have a little better understanding of what we're going to be able to build together here today in this webinar. Let me just leave this up and running. We have the Facebook filter up and running in a cloud instance, and basically what the Facebook is doing is recognize the faces in the video stream, and scrubbing this face into anonymized data, and that's what we are going to be building here together in this webinar. So inside of the filter runtime, we have this concept of a workflow. It's a very easy and elegant way to build your filters or build like a workflow. If you are familiar with the concept of chains, you basically have a very elegant way to plug in chains together. So you basically have, let's say that one, for instance, you have your stream input. That's basically our reading data here. We are going to be diving into more details into each one of those here. We have the Facebook filter, we have the stream output and the web visualization. So we are basically building this workflow here together. We are gonna jump into more details of each one of those. How do they look like, or I mean, how each one of those parts of the code means. But it is a Python script. You have to do some necessary imports. Don't worry too much about it. For building a workflow, we have a utility function called run-multi, which is a function very handy and very easy to use. You basically need to pass a tuple. A tuple contains a class and a dictionary that contains some configurations. Let's take the video, for example, the very first part of the workflow. You have your video input. I'm basically telling here the framework, hey, that part, that chain is gonna be a video. That video is gonna be is gonna be streaming for an source. I basically have to assign an ID for that video. In that case, I'm assigning vid in, basically telling the framework that's going to be a video that's going to come from input. Later in the code, we are going to see the video output. That's basically going to write or stream the video again to the downstream data of the pipeline. Actually, you can assign, we have a documentation, so you can assign, we have like a pre-built-in IDs here, so the filters can work, can have different meanings and works here, but don't want to dig into much of that right now. You basically need to assign a source for the video. In that case, I'm basically reading the video from my local computer here, but it can definitely be swapped to another kind of RTSP. For example, if you are reading directly for the camera here, very easily swap it here. You can pass some parameters to the source. We have an extensive documentation explaining each one of those parameters. Don't worry too much about it right now. For that case, in our webinar, I'm basically using sync. That is just telling the framework to run this filter as fast as it can. And I just need to assign an output to the video. Here, I'm just assigning the downstream data from the source to go to using the TCP protocol in my local host to the port 5550, which as I'm basically going to be using that. So let's just switch back to the code and see how that looks like in practice here. If I go up here, I have this script here that's called filter-usage.py. It is a Python script, very straightforward, nothing fancy here. We have just about 70 lines of code. We are creating a workflow to run the Facebook filter. Let's go down of each one of those steps and see how they look like and what they mean. This is a Python script. I'm doing some necessary imports. I'm importing the filter class itself. We are gonna dive into that in a little bit. I'm importing the video class, which is basically is a class for us to handle video streams or writing videos in the network. We have the web visualization and the utility. Those last two, I'm gonna be explaining then in a little bit because they are more easy to see when you're building our pipeline. I'm importing the Facebook filter itself. Don't worry too much about it. We are going to be explaining that in a little bit. And we have the main function. That's, again, a pretty straightforward Python script that you can run through your CLI and pass some parameters. Those ones are basically just the input video, the output video, and the FPS of the output video. I'm passing a dictionary with some configuration variables for the face blur. Don't worry too much about that right now. And if we go down and see the workflow here inside of the filter.run multifunction, that's where the beauty comes in, because we are actually building this pipeline of 5 steps here, basically getting the video, the last one that we saw before in the presentation, but I'm basically reading the video from the from my local computer and downstream the video to that port here. And that's where I can create a chain, because the Facebook filter, the second step in the definition of the workflow, is basically getting the input stream from the video, doing some processing here, and also putting the result in the port 5552 in the same network. The Facebook filter itself, it has its own ID here. So the filters, they internally have their network. They communicate with each other using the MQTT protocol, which is a pub and sub protocol here. So you can actually plug anything that you'd like in that network. So you can easily connectate your app or existing code using that environment here and just read into certain topics here. And it's very easily to use. And going back to the code here, the Facebook filter is basically downstream data, downstream the video to the utility. The utility, I like this one very much because it provides for you out of the box a lot of metrics that anyone working with computer vision would like to see. It basically, so you don't have to deal with calculating in your hand, how much is my FPS throughput or my CPU usage or a GPU usage here. It's very useful for logs if you wanted to see what is going on inside of your workflow. So I'm just plugging this in the workflow here to get those metrics out of the face blur. And I'm basically writing this output. So you can see here, I'm basically reading for the face blur that comes from the 52. and I'm outputting to a path in my local computer. But again, that part could be easily swapped to another if you wanted to. Basically, you don't want to save your video in your computer, you don't want to store it. You basically want to stream to another place, to another address here. You can definitely do this in that part here. And I have the web visualization, the last part of the workflow. I personally like this one very much because with just a single line of code, one line of code, you are able to spin up a web service, and you are easily, and you can easily see what is going on inside of your process. That can be very handy if you are a person like me. I like to work in a remote environment, so most of the time I'm just not writing code in my computer, but rather I'm actually writing code in a cloud instance, and I wanted to see what is going on inside my computer vision model, and I can use this web visualization to easily see what is going on inside my filter here. So that finishes our filter usage here, how we can build in a pipeline. And actually, you might be questioning yourselves, Navar, how can I write my own filter using the filter runtime? And actually, you can do this in a very easy and elegant way here. And actually, you can turn pretty much anything or existing code that you have in a filter here. That's very useful. Let's take the face blur, for instance. The face blur itself, it has three moving parts. The first ones are the model assets here. The model assets are, if you are familiar with machine learning, it can be any kind of model weights files that you have. It can be, for example, a PyTorch model, a TensorFlow model, an Onyx filing for your weights here. We have an inference code, and that is just boilerplate code that I wrote before, just doing some inference, find the faces here, and in post-processing code, plug those three things together, we have the face blur itself. And actually, to just turn the face blur into a filter, you need to write just one single class that I'm calling here, the face blur filter here. And I like to call this concept a warper, like a warper class, because I'm warping the face blur using the framework of the filter runtime to turn that into a filter. Let's see how that looks like. So I have my Facebook filter class here. We can do this very easily. I'm basically creating a class here that I'm calling Facebook filter, of course, because I want to turn the Facebook into a filter. That class basically inherits from the filter base class. The filter base class is a base class that is available in the filter runtime library, and basically is a base class for you inherit your all the classes or write your all the classes upon it, because it can provide for you out of the box and utilities, especially for infrastructure, so you don't have to deal with it. You basically just need to write two other methods for that warp class. The first one is the setup method here. We are going to go into more details about that in a little bit, but it's basically a setup method. You do some initialization. I'm basically initialization checking if the variables exist in a dictionary. I'm instantiating my modules here. We are going to explain that in a little bit. And that's pretty much it for the setup method. And you have the process method, which is a method that you must define upfront when you're writing your filter, when you're turning your existing code into a filter here. It's a pretty straightforward method. You basically need to write 3 or 4 lines of code, get some frames, doing some process, and returning the output. Let's see how that looks like inside of the code here. So I'm switching here to another script here. I'm calling this script here filter.py. It basically holds the definition of the Facebook filter class here. And the Facebook filter class is it's pretty straightforward. In about 30 lines of code, I was able to turn my existing code into a filter. Let's see how that looks like. I'm doing some necessary imports here, just checking a dictionary, nothing fancy, importing the frame in the filter itself that comes out of the box of the filter runtime. And inside of the definition of the Facebook filter class, we have the setup method, as I showed before. The setup method expects us to receive a dictionary, call it config. That dictionary can have any kind of keys that you want here, so it can be very easy for you to pass your data. If you feel that you wanted to pass your data downstream the pipeline, that's the way where you should put your code on it. And I'm basically check if the dictionary has those keys, the parameters, the detector name, and the blurry name, because the face blue filter, the face blue model, expects to receive two parameters. The first one is the detector name that I'm basically using this one, which is the UNet. I'm basically using this one, which is a deep learning model training a open source data set, very specialized to identify faces. So I'm basically passing the detector here on that line of code, and I'm passing the blurry name because we are going to be blurring and scrubbing faces of the people out of the frame using a Gaussian blur. So I'm basically instantiating my model here. If you are familiar with PyTorch or TensorFlow, you know that you have to instantiate your models up front. You have to load your weights files that's going to be stored in our local computer or even a cloud environment. That's the place where your code should be in, because when you are building the pipeline, actually the pipeline before being processed, the pipeline is kind of load up. We kind of preload all of the steps of the pipeline. And inside of each one of those steps, you're basically what the filter runtime does internally. It basically calls the setup method to do some instantiation here. So if you feel, for example, that you want to connect your existing code to a database, you're gonna be needing to use that later in your downstream process. That's the place where your code should be inside the setup method, and just leave the process method here, the second method, the one method the another method that we must have to write for ourselves. You basically just do not instantiate anything here or create some new connections here, because every time data is being read from is being fed from the stream here, the process method is going to be called constantly. So one cool thing, you don't have to deal about, for example, I'm gonna batch images here, how many images I'm gonna batch here. You don't have to deal with all of that. If you have been working as a computer vision before, you know that in some cases you have to worry about batch size here, how if the images are gonna fit in the memory of the GPU or something like this. And you don't have to deal with all of that, because the infrastructure that the filter runtime provides for you deals for you out of the box about this. You basically need to assume one thing. You basically need to have an assumption that you are going to be processing one frame at a time here. And that's basically what the process method is doing here. I'm basically getting the frames from the topic. The topic gets called main here. I'm getting the frame object. That frame object has an image here. I'm passing the image to the face blur here. I don't want to dig into details about the process of the face blur, because I just wanted to focus on the filter runtime. But what the face blur process frame method is basically doing is getting an image. The image is an NumPy array. If you are familiar with that concept, it's basically a representation of the image inside of the computer, but it's basically getting this NumPy array, is running this deep learning model, the UNet, to recognize face, find the face, and apply some Gaussian blur on it. And I basically return this output. This output, again, is another NumPy array. And I just have to create this object, the frame object. The frame class itself is another base class that exists, that lives inside the filter runtime library. And that class basically takes as an input the output. You have to pass an image equals to output, which are basically passing the array downstream that data here. You're passing the configuration dictionary here again, and assign some format here. I'm just assigning BGR here, but you can definitely use RGB or CMYK or any kind of format that you want to pass your data. And I'm basically returning this object here. So in just two methods here, we are able to turn our existing code into a filter and plug into, so we can kind of plug this and create this workflow here. But actually, we can create like a more extensive or a more advanced workflow. per that say. As I'm not sure if you remember, but I show you all before a video of the of kids getting cups from a pile, taking those cups out from the pile and place those cups in the table here, creating a line of those cups here. So we kind of think, hey, what if we could go back and instead of just anonymize the data, scream the face out of the video, it would be nice if we could just counting cops. How many cops are going to be placed inside that line here? And that's it. That's basically what one of my colleagues did. So she wrote that code, the cup count code, that basically count cups, counting cup. That is basically is counting cups in the table here, and that's basically what she did. She actually trained this deep learning model, specialized it to identify cups, predefining a region in a table. So she wrote that code, turned that code into a filter, and we can actually easily plug those two things together using the filter runtime library in a very easy and handy way. That can be very useful. For example, an existing engineering team, each one of the members are working independently, and they want to be able to have a common infrastructure to build things together. That's something that's very useful, and filter runtime provides for you out of the box. Let's see how that looks like in code here. I have another script that I prepared up front that is called filter-chain.py. I'm gonna give you a spoiler here. It's pretty much, it's very similar to the last one that I showed you here, and it's a Python necessary imports, the same imports as before, the filter, the video, the web visualization, the utility here, the Facebook here, and here's the difference here. I'm just importing the cup count filter. I wasn't the person that wrote that code here. It was my colleague. She just wrote the code and published that code in our Artifactory. I'm basically importing this code here, using it as a library, importing that filter here. And if we go inside of the main function, it's pretty much the same as before. I'm receiving the input video, the output video, the FPS, the configurations for the face blur. And here's another difference. Since the camp count filter is a filter itself, is expecting to receive another dictionary. Don't worry too much about the key paired values in the dictionary. It's basically the model artifact, the confidence, the table region, where our model should be looking inside of the frame here, another of couple other configurations here, but don't worry too much about it. And if we go down, we can see that the workflow, it stands pretty much the same as before. We have the video reading from the same path, downstream data to the same port, the face blur doing some processing here. And right after the face blur is downstream data to the 5552 port inside the TCP network, the internal network. And I'm basically plugging the cup count filter basically to read frames or to read the stream video, the output video from the face blur, connecting it to the cup count filter. The cup count filter is going to do some process there. It's going to be running the model, identify cups inside the frame, counting the number of cups there, and I'm basically plugging this to the output of the face blur and downstream data to another port. The rest remains pretty much the same. We have the utility here and calculate metrics of both filters, the face blur and the cup count filter here. We have the video, again, pretty much the same, and web visualization. Let's leave this running and see how that looks like. I always like to get my commands prepared up front. So let me just paste this here, leave this up and running. It's going to take a few seconds to load because we are running two deep learning models in the same instance. So, by the way, that's the kind of output that you're going to be getting from the utility here. It's basically telling, hey, Navar, that video is being processed with about 11 to 12 FPS throughput. We have some other CPU usage here, memory usage, and lot of other cool stuff that you can place here. Let's switch back to the browser, refresh it, and see how that looks like. And there it is. We have our face blue filter, pretty much as the same before, anonymize the face of Kit here, but right now we have a deep learning model counting cups inside the spray defined region right above this purple line here, and the number of cups are being written in the upper left corner of the video here. So what I wanted to demonstrate with you all is how we're able to easily integrate those two models here. I'm not sure if you're familiar with machine learning, but those two models, they actually have separated dependencies here. They have different things to work on. But with this very concept of filters, we're able to easily kind of plug those models together. And actually, you can do this. I'm not sure if you can see this, but it's running a little bit slower than before. The reason why, it's because we are running two deep learning models in the same compute instance here. So you can actually do this in a more efficient way here. Instead of defining your workflow in your code environment, you can actually define this in a higher level environment using containers, actually distribute those containers here so you can get a better parallelization strategy, you can get a better processing, a better FPS throughput. But that can be a lesson for another lecture, and I will be happy to talk with you all about this in the future. That's pretty much what I wanted to demonstrate to you all here. So again, thank you very much for joining this webinar. I'm very excited that you all taking an interest in learning here. And I would like to open the floor for questions that anyone might have about what I just showed you guys. And thank you again.
If there are no questions, we're going to close out the webinar. Thank you so much, everyone, for joining.